Hey everyone, I'm David Room. Tonight we're going to be working on some Python game dev, working on my retro space combat game, and we're going to be focusing on some functionality relating to planets. So I've been sharing some work that I've been doing with adding new aspects to the simulation, including gravity, forces, um, some orbit stuff, and now we just need to do a little refactor of how we're handling planets. And then there's a couple things too relating to um, just doing some calls to make sure that the dynamic skyboxes with the planets are getting updated. So just kind of doing some refactoring, tying up some loose ends with planets should be a pretty chill time. I'm going to throw on some white bat audio as usual, and this time we're going to try strange eons. So I'll get that going and we'll get right into it. I had a good first day of the work week today, but I just feel like I keep getting busier and busier in my job, so it's good at the end of a long day of programming for work to do some fun programming. So let's get right into it here. So I'll just show you here. I have a system for doing planets, which I built, and in the past, I've just kind of set these things up in the skybox just to kind of look a certain way. But we're trying to get into some more realistic simulation stuff here. So we're moving to a system where we actually have an understanding in the code of what the planets are, how big they are. We've implemented double precision positions so we can actually describe the relative locations to us. And there's a little bit of fakery in how they're being presented here. They're in a special background layer, and they're rescaled to sort of look like they should look. But the whole thing is getting much more rigorous. And as I got into it, I kind of realized, okay, we've got to do a little bit of a refactor now. So let's get right into that. And before I forget, I'm going to update the config so that we get a nice big screen here. And as usual, Notepad++ freaks out on me. Okay. So, yeah, so currently I have a data structure called the celestial body, and I use that, or elements of that, when I'm building the skybox, and then I can have celestial bodies in the game, in the simulation. And something that I have in my game is I have sort of a two-leveled system for managing information. I have one set of objects that represents the complete set of information about something, including the game state. And then I have another object that represents kind of like the offline static information about something. And I realized that I didn't do that for planets, so I'm going to try to refactor planets quickly to use a system like that. And the nice thing about having a system like that is then you can interact with those sort of static data structures completely separately from the game code. And in my project, I have the game code, but then I have other things that I do with these assets and this information. So we definitely want to do some kind of separation like that. So what we're going to do is we're going to separate this like name, mass, and radius thing into its own thing. So just like for entity, we have a info that has some kind of offline info about the ship or whatever. We're going to do the same. We're going to do the same thing here with planets. And I think the place where we want to put these is in TDS. So TDS is the module where I kind of have these offline info classes. And I think TDS, if I remember right, stands for Tech Data Structures. So I think it makes sense to put planets in there. Because we might be wanting to use some of these constants and things that are specific to planets in simulations, these sort of like offline simulations or calculations. So call this info, and we'll call this planet info. Well, let's see here. Actually, we'll just call this celestial body info. We kind of have a redundant name here, but that's okay. And we'll see in a second how much cleaner this makes how we work with these things, because my project is very focused on code, and I set up the missions and different things just using code. So I'm trying to build a nice interface using my code to do the things that I want to sort of construct the missions and different content for the game. This is a good song. It's called Underworld. This is a White Bat video that I haven't listened to before, so hopefully find some good new tunes. I need to make a custom playlist of all my favorite ones, because I definitely have favorites. Okay, and then what we're gonna do is, let's see here. So now we're kind of doing this awkward thing. And I have this content, this planet's content directory. We might still be able to keep this actually. But instead of having these kind of awkward things, we're just gonna make we're just gonna have some static planet infos here now. So this eliminates some redundancy here. So TDS import TDS, and then this equals I always think it's kind of fun, part of building a game, to start making these sort of collections of, you know, real world data or like reusable bits and pieces, like planets or, you know, different things. Kind of feels like you're building a collection of things. I like collecting things IRL, so I always find this part fun. And then we're gonna we'll make a build chill body where we take a celestial body info and return a celestial body. Now, okay, let me check about this. We might want to refactor this a little bit. So where do I load that model for that guy? Planet model file name. Okay, so it's like it's completely detached. The model file name is like completely detached. I think that's okay because we might actually want to swap different model file names. We should put those model file names in this content directory so we can deal with it. So, okay, so okay, now this gets simplified. So we're gonna go like this. Build celestial body. And it's dot const dot ins. And then we can use this like this, uranus.info.radius, yeah. This. So this kind of simplifies it, and we can actually even radius, yeah. We can actually tweak some things here too once we get this working. Okay, yeah, and now we've got a bunch of these things to fix. So the fastest way to find all these, I think, is just going to be to run it and fix them. All right, seems to be up and running. Now, I can actually do something kind of fun here, which is make this generic, and then this this will make a little bit more generic. This will just call it planet position default. Nothing super special about that anymore. Okay, let's see if this still works. Cool. Okay, now what we're gonna do is add another planet or two. So start cleaning some of this stuff up. Do this. And we could even get fancy with it. Trying to see if I do this thing sometimes where I sort of specify a lot of different things as constants. It might be overkill, but let's just do it for now. So Vidya Shankark P9192 says hi. Hello. Then you can kind of put things in, when you do this, you can kind of put things into nice dictionaries and stuff, and you can look them up very reliably. You can also just do something like this where we can get them by name. If we want to. Something I like doing too, I don't know if I've really talked about it on here, is I like putting these module level constants in a class called const, just because it sort of hides them all from your global namespace. In Python, you don't always have good ways of making namespaces. So, you know, in the past, maybe I used to tend more towards just sort of tossing everything in giant files and stuff, but I do feel like it kind of helps to try to control things, especially when you're like, if you're trying to, you know, manually write code and you're looking at project structure and stuff like that, having some structure to what you're doing helps for sure. And actually, we don't even have to make this a variable. We could just do this down here. Okay, and let's see if it still runs. We still get our planet. Yeah. Okay, so now the fun thing is we should be able to just swap this out with a different planet. So let's add Venus, because that's another one that we have a model for. That times 10 to the 23 or 10 to the 24. And just as a gut check, yeah, Uranus is 10 times 20 times more massive than Venus. Okay, and the mean radius is that many kilometers. So if it's that many kilometers, then we've got it would be that many meters, but we can't do that. We've got to add 6. I think I did that right. Let's just double check. Let's put Venus in meters. Yep, 6.0518 times 10 to the 6th meters. Okay. And then this does have a I was thinking before starting about how I'm going to go about making some additional planet models, and I'd really like to do that, but I think there's a few steps there that are going to be a little bit too involved to do on the fly tonight. Alright, let's try this now. So we should be able to just swap out our planet with a different one here. Yep, there it is. Perfect. Okay. Yeah, and it's so much smaller that we have like next to no forces on us compared to Uranus. Okay, and let's just add the moon in as well because I have that. Let me just call that Luna. Indresh534 is in the chat. How's it going? Hope everybody's having a good night. I hope you're encouraged to work on some of your own creative or programming projects. I know I like to watch live streams while I work on my projects. And if you're working on something cool, I'd like to hear about it. Especially if it's like a game project or a programming project. Yeah. So this would be in kilometers. So 7.3 meters. And let's see, does that make sense? I don't know if I got that quite right. Okay, so Ankit says, what's the game about? So it is a space combat game. I'll show you what it looks like here in just a second. Just gotta make sure. Oh yeah, I'm off by a factor of subtracted. Yeah, 374. So I don't know if you've played any old space combat games, but like I was very inspired by some games that I played when I was a kid, and actually they came out even a bit before I would have been old enough to play them, but I played them when I was a teenager. And those games are Descent Free Space, Star Wars TIE Fighter, and a game called MechWarrior 2. And these are older like sci-fi space combat simulation games, and they have a very cool look to them, and they have a neat mood, which is kind of something that I'm trying to go for in my game as well. Kind of dark and moody, and some kind of maybe horror elements to them. And I have a personal project where it's my own sci-fi universe, and I've written some novels in it, and I'm working on this game project and doing different 3D art and stuff, and it's fun. It's fun, like working on projects that are drawing inspiration from those things that you enjoyed as a kid. I know child me would be really impressed and think the projects that I get to work on as an adult are pretty cool. So yeah, it's fun to do that. Okay, so here let's try the moon. So I'm just testing swapping different planets in here, and because we're setting the position of the planet as a factor of the size or the radius of that planet, they're all like going to be pretty big, but we can also experiment with like what would it look like to be like have the moon, but if we do the moon but at 3 times the radius of, say, Venus rather than the moon, it's going to be a lot farther away and a lot smaller. Oh, so Ankit says, oh damn, graphics look cool. Thank you. So the graphics are kind of an interesting style. I can talk a little bit more about them. So yeah, see, it's very, very small. So let me, oh, interesting. We got a little math domain error, I think maybe because we're too far away from the planet. Some little things to work out here. Um, so, okay. Yeah, so Ankit says we can do that in Python. Yes, and people often are surprised by how my game looks and the fact that I've written it in Python. But Python is a real programming language. You can do pretty much anything in it. This game is written using a game engine called Panda 3D, which was actually developed quite a long time ago by Disney, and they used it in a couple of MMOs that they had maybe about 15 or 20 years ago. And it's actually kind of a thin wrapper around C++, but it's very well documented, so I like it. And just a note about the graphics. So the graphics use this kind of actually, that's very distracting. They use this kind of flat shaded style, and this is taking inspiration from those old games that I was talking about. So Free Space has texture mapped graphics, but TIE Fighter and, well, actually, I guess MechWarrior 2 does some texture mapping too, but both TIE Fighter and MechWarrior 2 have these very beautiful graphics that are done back in the days of DOS. A lot of games used to run in 256 colors, and so early 3D graphics would have these kind of beautiful smooth shaded gradients, and it's very beautiful to look at. And this game uses some rendering methods that are a lot more modern than those games would have used, but but I'm trying to kind of create that impression of those striking smooth shaded graphics. Plus, I don't like the idea of having to do texturing and UV maps and stuff like that, so going with the style where everything is sort of flat shaded keeps things simple. And then you can do some neat things like with vertex colors, like I'm doing for the planets. So, or like on the space station, all the windows are just actual geometry, so you can do things like that. Zapman SI 107 says, do you use Numba? So I don't. I've heard about Numba. I have not ever had a reason to use it. I do a lot of machine learning and computer vision stuff in my day job, so I've used like the ML frameworks like PyTorch and stuff, and NumPy, and I use NumPy in this project when I've got a mesh processing library that I use to actually create all of the content. So the models and stuff in this game are actually created with Python as well. But I've never used Numba. I've heard a little bit about it, and I knew some people at my old job who used it, but I've never used it myself. I see Doug Wise here. Yeah, station tour to show off the lighting. Unfortunately, with the changes that I'm making, we see some shadow flicker on the station, and I've got to figure out, I need to sort of rewrite the shadow map system to be a little bit smarter about where the origin of the shadow map is, so we don't see that kind of flickering. So Ankit says, I don't know if you ever heard about Ace Combat. Like, the graphic looks similar. The game is built on C++, I guess. Yes. So lately, a lot of people on Twitter have been, or X, whatever you want to say, they've been sharing screenshots and videos of like the Ace Combat games that I think were on the original PlayStation. And yeah, that does look really similar. I noticed there's like the HUD stuff looks really similar, And yeah, like there's a lot of differences, I think, from how PS1 would be rendering things versus the way the DOS games that I'm kind of drawing inspiration from would render things. But it is a similar kind of level of technology, and it's got a similar look to it. And I think you're right. I think Ace Combat would have been written in C++. For sure, the later ones, like on PS2 and later, would have been written in C++. And I could be using C++ for this engine, it's just I'm not as familiar with C++. I don't like it as much. I really like Python as a language. You can do some really interesting things with it, and it's very fast just to get your ideas out, so that's why I prefer Python. But there might be a few parts of this game at some point that I do actually rewrite in C++ just for speed or whatever, so. Okay, so let's think about what we want to do next here. So we've got these new planet data structures in place, and I'm pretty happy with that. And one thing I want to do is there's a couple little tweaks that I want to make to the orbits UI. So there's a UI in here where we can kind of look at the properties of the planet that we're orbiting. I'd like to add the name of the planet to this. And then we do have to do the thing where we actually update the scale of the planet with the position and distance that we are. I'm just gonna try something just quick. Probably the moon is gonna be the best candidate for this because it's smaller, but I just want to see if we accelerate like crazy and then turn the time acceleration up. Can we actually get noticeably farther away from that station? Enough that we would expect to be able to see the planet getting smaller. Because if we can't, then I'm going to need to set up a different sort of scenario to be able to test this out. But I think we can go fast enough, and the moon is small enough, and we're close enough to the moon here that I think we might be able to do it. Yeah, you can see like how big the changes in the orbit are as I'm moving, and you can actually see here, see our orbital period here is small enough that you can actually see that, oh geez, yeah, we're not moving super fast actually relative to the other combatants in this case, so that's interesting. So the way I've set this mission up is I'm putting myself in that station at orbital velocity, but not the other planets. And in this case, the orbital velocity around the moon is slow enough that yeah, we're not even out of the firefight here. So let's see here. If hopefully I'm invulnerable. Can I get noticeably farther away? Let me drift so I can go way faster. Oh, math domain error. Okay, so I'm getting a math domain error here. I've got to trap this guy somehow. So uh, I think what's happening is I'm probably moving into maybe a hyperbolic orbit or something. Um, but let's see here. So how do we want to handle this? Maybe let's see here. Because I want to be able to visualize this. Let's see here. If I try... There's probably a way that I can avoid that math domain error, but I don't feel like looking it up right now. So if I try accept... failure is true. And then if fail, we'll just make an orbit that's just a bunch of points just at the current head, I think. Yeah. So Ankit asks, how long have you been working on this? So I've been working on this game project for about 5 years, because I think I started it in 2021. So it's just kind of it's been a fun personal project for me over the years. And there are a lot of different aspects of this project beyond just the game. So when I get bored of one aspect of it, I switch over to another. And I've come back to the game now because I want to get some of this physics stuff nailed down, so I can use it in other aspects of the project. I do some Blender renders of like more realistic versions of these ships, and I want to be able to do some cool space combat stuff, like visual effects. My goal with that side of the project is like, I'd like to make something that is on the same level as stuff that you would see on TV, or at least maybe you would have seen on TV 10 years ago or 20 years ago. So cool. This is let's see here. Let's see here. I just got to make sure I know where said. That's fine. Can I just do... I think I can just do this. quite tell which direction I'm going. There we go. Now, if I zoom in here, yeah, so you can see, it's kind of hard to see actually, but you can see that it is, I am like moving noticeably farther away. Now, if I turn time acceleration back off, and if I drift, so now I'm going quite fast, you can see we're still, like the moon is still, I think, looks the same. But now we're gonna add something so that we're gonna update the position of the moon so that we can actually see it moving away. Okay, so it's real. Let's update planet. So right now we call update planet when we build the skybox. But what we're going to do is basically call that same thing every tick. So in our main loop, in run combat, at the very end, actually, total results of collision. So everything should be in its final. Let me just figure out where things are going to be in their final positions. Should be after the collisions. Yeah, because now we can update traces and links and stuff, so this would be the right place to put it here. Oh, am I actually just calling this in here? Where am I calling? Okay, yeah, I'm literally just calling it right when I make the planet. Yeah, and this isn't actually quite right because I need to do this relative to the camera. Interesting. Okay. Yeah, it's probably not showing here because I didn't. It's like it's very small. But this definitely needs to be adjusted. And this, let's see here. Collision zoom, traces and links. So planet. Let's see, skybox rule it's called. Let's update planet. Let's see, skybox. Where do I keep this skybox? Okay, space lighting. Let's see here. SPL. Game.SPL. Or space lighting. Skybox MP. This is easy. That's just body.radius. Position is a little trickier. Let's see here. We can get it close. I think what we want is we want because the position, that's its absolute global position, and then we want to subtract the origin because we do this floating origin thing. And let's see here. Let's see, this floating origin is double precision. And then 3. Then I think we also want to subtract. Do we want to subtract off the camera position? Or do we want to add the camera position? Let me think about this. So this planet's way over here. So here's our origin. Here's the planet. Now our camera is over here. Let's see here. Give our camera position. I think we want to. Do we want to? I don't know how much difference it's going to make. It's too late for me to think about which direction this goes. Well, actually, here, let's think of a simpler example. Say we're all on a line, right? Just on a 2D line. We have our origin, we have the planet. And let's say the planet was at 10 and our camera was at -2, and the origin was at 0. We want to subtract the camera position because we want to add 2 to that position. So I think we got to subtract game dot let's see here, base dot, I think it's base dot camera, base dot camera dot base dot camera. Right. And we might actually want to leave that off, just because the camera is going to be so small. I'm gonna hypothesize something here. So we definitely want this, but this might be so small that it just doesn't matter. Not really matter, but it might make the and it might make the planet look unstable. So I think we can probably avoid that. Now it's complaining about this. Oh, interesting. It actually wants a back 3D. Interesting. Okay, so convert this guy. Pop this out. I sort it. Now, hypothetically, tuple. Why is this a tuple? Oh. Okay. Yep, okay, so that's expected. It doesn't really look any different. Now, let's fly away real fast and see if it gets smaller. Okay, now I'm gonna we're still accelerating. Now I'm gonna stop accelerating, but I'm just gonna drift. Now, yeah, that seems like it's smaller. Yep, look at that. It's slowly getting farther away. And it's Yeah, it's pretty slow. Like I don't see. Here, we'll accelerate further here. It doesn't really seem to be super unstable on a short time frame, so yeah. Cool. So we're about 1,300 kilometers away from that station. You can see how much further we are. And then if we let ourselves decelerate here, we should see an orbit appear when we slow down enough. And I still have the station set as my reference point for the for velocity. So if I try to match the velocity of the station, I think, yeah, we should see. I think we should see an orbit appear. Yeah. Okay. Nice. Look at, you can see. Yep. There we go. Oops. Yeah. So there's our. So there. Oh yeah. See, we're still kind of like on the verge of a. Like a hyperbolic orbit, I think. Yeah. That's cool. And let's see if I, yeah, so now if I slow down to 0 relative to the station, and let's just see now what it looks like. That's too bad, our velocity indicator is kind of messed up, but if I turn the time acceleration on now, can we see that movement of the orbit around the moon? Not so well, unfortunately. I think, let's see here. What is the period of orbiting around the moon? Let's see if Gemini can tell us. Yeah, 6 hours. So even with some time acceleration turned on, that's still pretty fast, or a fairly long time. There's a missing. Well, I feel like in general we've gotten this working. Let's just cap things off by adding the title to the little orbit UI. It's funny that here we're still like we're not so far behind that our combatants are out of range here. Let's fight a little bit here. I think this is the first time that I've, oh yeah. There's a couple, this is the first time I've played the actual combat after changing the distance to use kilometers. So that's kind of fun to see. Sometimes little things like units can just give things a different feel. Oh, the other thing that we've got to do is we've got to get this grid in map mode to use the reference point rather than the absolute coordinates. We really got thrown way out there by that collision. But we can bring the distance back pretty quick. That's funny. Okay, cool. Yeah, let's add a little title to that planet quick. And then we'll call it good for tonight. So the simplest way to do this is going to be just putting it right smack dab in the middle. Okay, so display in P. We'll just call this title text in P. This is actually quite long, isn't it? We probably need to... Let's see, where do I set texture? Set text. There. Probably refactor some of this. UI.title text np.node set text body dot name, and then UI.title text np dot set scale and black, and gotta fire this up. Parent to display in P, and let's see, where do we get the font info? That's funny. Let's see, when we rate this, yeah. So that should make text right in the middle. Yeah, but we've got to set the shader on it too, to get the shader to work like right. So let's see here. Piece 2 shade. This, and then we're also going to add the text and okay. Nope, not quite. What went wrong here? Oh. Title text NP. That's interesting. There's sometimes some weird stuff that can go on with shaders. For some reason, the shaders on some of this text are getting set, but not others. It could be that there's something... There's a step where I set up the shaders on all of the text. And is that what is... I didn't think that happened until game init, but I could be wrong. It's logic just like this. Set shader game.shaders. Yeah, set up UI filters 2D. Set up UI filters 2D. This might be a mystery for another time. And if these are getting grabbed, why isn't this one? Like, what is... What is setting the shaders on those guys? These text nodes here, but not on... That's very strange. There's 2D. Income gauges. It's 2D. Do I ever set this on? Let me just check and see if this is what's actually... It's actually what's doing it. Oh, look at that. So... Elements. I could have sworn that we were like descending into children here. Okay, maybe maybe a better way to deal with this is going to be debug this thing. So like let's see what, because this should be being invoked on all the stuff that we want this to be on. So like let's see what's actually here. Okay, so set shader. Oh, if it ends up being this, that would be really funny. It was just a priority issue. Oh, actually, I bet I know what's going on. Yeah, I know what's going on here. We need this. We need this logic right here. That is almost certainly what is going on. So we need to yep, and that's why text shader. There we go. Okay, there's two different shaders that we needed to apply, and I wasn't handling that correctly. Let's actually just for simplicity do that. We can get rid of this printout. And let's see, where was the original? And this is kind of duplicate code, but I don't feel like fixing it right now, so we're not gonna. But yeah, this is actually. Do we just want to? Yeah. I wonder if that is actually. There might be some alpha. That looks right. I don't know. Could be something else is passing this on down. Who knows? We're gonna set this color to that's not working. This might need to be one. Oh, that's the wrong. Well, let's try this. Nope. Something is setting the color. Something is setting the color. That's what it is. Something setting the color. Yeah, the call that's setting the color. Okay. Now, what we want to do is instead of setting the color in here, we want to do this. And set the color here like this. There we go. Now, if we want to, we could make the title bigger. Like 3 times the size or something. That looks a little silly at 3x. And that should be centered too, but I don't have time to do that right now. Oh man. A little bit better. Could also do this. But I think this works a little bit better. Let me just see if I can remind myself how to find the width. Oh, Let's just get width. So we can just do something like this. We can just do like this. Now we should have a center title. Nope. Oh, we need to do this times the scale. Let's see if this does it. Yep, there we go. And let's see here. Yeah, I kind of like the look of that. We could do the text. Above or below the planet too, but I don't know if I really want that. I like having it kind of in the center. And then eventually I want to have the entities like in the targeting system too. But I think for now, yeah. Yeah, I agree. Ankit, I think the center looks better. And that's cool to see the orbits changing like that during flight. That's really cool. One thing I can do too is let's see here. What is this? Orbits.update. Orbits.update. I don't have to do this unless this is showing. So if HUD.orbits, let's see here. I think it was the display np dot is hidden. Yeah. HUD UI. Let's see. Dot display np. That is hidden, so not hidden. We can do this, and let's just fix this while we're at it too. Oh, try changing the font though. Yeah, I have a couple different fonts that I use, and I have a title font that would probably look better for the big title. We'll experiment with that another day. But yeah, like you can see, this when I switch modes, I have like a different font up here, so I could use that one. I think that would look pretty cool. And is this still updating? Yeah, it's updating properly, but it won't update now when we're not actually even showing it, so that's good. All right, well, I think we've accomplished a lot here. I'm just checking my list to see. I mean, we confirmed that well, we added and then confirmed the actual like skybox scaling is working. We kind of refactored planets, and then we did some nice little improvements in terms of how the little orbits UI has a title now, and like, you know, all this stuff should update as we switch to different planets, right? So where's my mission 4? Right, if we switch this over, you see Venus there now? Yeah. So yeah, everything looks great. I think we're gonna call it there for tonight, but thanks to everybody who came to hang out. So Anki asks, nice, you stream daily or like occasionally? Yeah, usually I do a couple times a week. I'm trying to get into it a little bit more just to make a habit of it more. But yeah, definitely watch. I usually I'm shooting for like at least once a week, but maybe, you know, maybe more often going forward. And some things that are coming up, I think we're going to be doing some other neat stuff with some like mission planning stuff. There's also some other physics stuff, and there's some more ship system stuff coming up. So we're working on energy and heat usage in the different ship systems, and we're going to be adding drives to that, and thrusters to that, which should be fun. So yeah, a lot of stuff. And then eventually, maybe in the next couple weeks, if we can get some neat scenarios going that use all this stuff, we're going to circle back into the high detail art and take some simulations of some combat scenarios into the high detail stuff in Blender. So that's kind of the end goal of a lot of this, is actually not so much the game itself, but like just getting some really cool dynamic animation stuff going. Doug Wise says, yeah, spoiled with all this streaming lately. Another fun one. Yeah, thanks. It's fun having you hang out. I've just been trying to push myself and say, okay, if I'm going to sit and work on my project, just stream and see who shows up, rack up some hours, maybe get some new subscribers. So appreciate everybody who's hanging out, everybody who's subscribed, and regulars like Doug. It's always fun just to go live and know that you're probably going to be in the chat. I really appreciate it. So yeah, everybody, thanks again for coming. Have a good night, and we'll see you next time.